is Japan Kilo 1 Bravo Quebec Sierra. Good evening. Yeah, thank you for your call. You are 5by757. My name is Yoshi. Yankee Oscar Sierra Hotel India QTH near Tokyo. How do you copy? Over.
All right, today we're going to attempt to commission the Foursquare. I might get waylaid with other things, but we'll see how we get on. So what is a Foursquare? It's an antenna with 4 elements. It's behind me here, you probably can't see it, but I'll throw some cutaways in. This is for 40 meters. So you've heard of a two element phased array. That would be basically 2 driven elements, one with a phasing line to delay which way your signal's going to go. Foursquare is slightly different, as they're all driven, and to be honest, it's slightly beyond me how it works. But basically, there's a bit of signal coming off every single one, and combined they go in one direction, and you can switch it in 4 separate directions. We're in the UK here, which is ideal. Northwest is going to be USA, northeast is going to be short path VKZL, Northern Europe if you like, but I could reach that with a dipole frankly. Southeast, obviously southeast, that will be southern Mediterranean all the way down towards sort of Africa, and then southwest. So that's a long path, VKZL, that's Brazil, South America, Falkland Islands, things like that. So I'm just taking this box apart to review the wiring. So this has 1 piece of coax going to it, and then very, very specifically, there are 4 exact 75 ohm lines, and we've calculated these need to be 8.88 meters long to get the exact size required. 75 ohm coax, and I've got to thank Stefano actually at Messi Paoloni, who sent me a reel of that coax for this job. So you can see we've got our transmitter, our single line from here, and the switch cabinet at the top of the field down to the bottom of the mast where the Foursquare sits. Then we've got 2, which is our default position. That's going to be northwest. Number 1, so go in order. 2, 1, 3, 4. I didn't realise that. So 1's going to be southwest. 3 is going to be northeast, and that's southeast. This also requires a 50 ohm dummy load. It's what they call dump power. Any imbalance in the system needs to go somewhere, and rather than cocking up the system, what it does, it sends it to a dummy load. And on 1500 watts maximum, a well-tuned system should be well under 100 watts of pure resistive dummy load. So we've got a dummy load for that and a little patch lead. This is going at the bottom of the box, and let's try and get this working. We realised we need a complete switch box. We've got 2 stations, both with 2 VFOs. So we've got 4 coax going back to the shack, and each radio can select any one of 8 antennas. And this comes with something called an OM module, and the OM module is programmable. And instead of using the Foursquare controller that DX Engineering sent for me from Comtek Systems, we use the OM module. All right, so we're using a software controller, which ends up with a bit of hardware. We're not using the controller that came with it. If you know how that works, then good luck to you. You're more of a man than I am. But these are going to be the relays, I guess, on the top here. We're going to dry fit this and press some buttons, and just one properly clicks. I've just been informed that my microphone cut out then, so I've got this massive battery bank powering this mic while I charge it up. So we're going to dry fit this with a short piece of coax, a short lead, and make sure on the software, we'll bring the laptop out, we'll remote control the inside, and we'll click some buttons and just make sure it goes clickety-click. That's what we're going to do. While my microphone is charging, a lot of people have asked, will the tower with the Yagi on it in the middle interfere with the Foursquare? I have done some basic modelling, and because it's not tuned for 40 meters, it should almost be invisible. And the other thing is, it's right in the middle of the array, so it'll kind of cancel out, if you know what I mean. I've got to thank Martin, actually, who helped me a few weeks ago put 700 meters of radials in here. I will put a link to that video in the description. All right, so I've prepared black, which is number 1, red is number 2, and then I've joined two together with it's a ground. And I happen to know, because I've gone all through the manual, is that we need to connect black to number 9 and red to number 10 on the OM module, and the ground is going to go to ground. And I've done all the multimeter tests, so hopefully nothing's going to blow up. Let's just connect it, see what happens. One and two go to 9 and 10. One is black. Black is 9. Oh, that's a bit small. Right, bottom is the 4 square. Whoa! That is north west, northeast. Can't believe it. So we're going clickety-click. So northwest. Brilliant, brilliant. I'll just clip this microphone onto the unit. You can hear the clicks. So we're looking for these lights on the top. Northwest is the default position. It needs no relays at all. Northeast should have 1 light on. Southeast is 2 lights. Southwest is effectively the other light. I'm just making the earth lead, the one with the negative, and I thought I'd just heat shrink it, make it look a bit nicer. It's a glue lined heat shrink, so it's you know, squashy, so kind of that's all right. And I need to fit this slightly better onto the thing. Anyway, I'm waffling. Let's cut these off. We'll keep the orange for a rainy day. I'm going to do brown and white is ground, then we'll do blue, then green. Blue is 1, green is 2, or 9 and 10. Oh, I've set up a little working area here. I'll use this chair as my table. All right. So let's strip a bit of this back. That is slightly precarious. I wonder if there's a better way of putting that. So I've still got some room. Okay. I'm using both cores. I probably don't need to. In fact, the book of words say that a single core of Ethernet is good enough. But just in case, I'll join them both together. Brown, that's that one. Brown. Okay, that's nicely seated. It feels just nice. We need some sort of cable tie, I think, don't we? I better get a cable tie, you know, to stop that. Oh, we're supposed to put it in there, are we? And that will help? Yeah, I think so. I've got the wrong, oh, drat. The wrong screwdriver. And I'll drop this screw now and never be able to find it. So that would assist, won't it? Okay. So I've got to say, I sent an email to Tim Duffy K3LR, the DX Engineering top brass, and said, hey, I want to put a 4 square in. Can I get a deal? And before I know it, Scott in sales just sent me this. So thank you, DX Engineering. So I've intentionally taken out the brackets to put it on a pole because we're going to fabricate a way of keeping it in here. Not right now, I'm just going to lay it in cable tie this cable out the way, because the mower is going to come along and want to nab that. I could literally do with about 3 or 4 inches more, but we don't have it, so it's tough. All right, so next job, dummy load and the coax. So this is actually an old patch lead from, I don't know, CB or something, but it's not high power. And we can put the dummy load on there, so we'll just have to make it look nice. Do we need ferrites on this? I've got a ton of ferrites for this whole thing. I haven't tested this, but yeah, I'm sure it'll be fine. Alright, simple little dummy load at the top, old patch lead. This has to cater for a maximum of 100 watts, remember. We've got the main transmit coax to come into here, and the coax we're using is really tough, nasty stuff. It's ever so nice coax, but it's going to have a bit of a bend. Everything's got to go down that hole. So this is Mike's work from a couple of Saturdays ago. I think we'll start with the furthest one, which is over here. Right, there's quite a lot more work here because this wire I don't want anywhere near that metal. We could end up with a sort of we could get blow through. In other words, that could go spang. So I'll need a little standoff. I don't know how I'm going to do that yet. I might look at a little plate that we can put in here, like off of the old DXCommander or something, just to hold that away. And the other thing is, I've got to fit a coax to here, and I've got a lawnmower, so I don't know if we come up and down or what. I mean, I just haven't, to be honest, thought this through. Well, I've thought it through. It's not until you sometimes physically do these things that you go, oh, hang on a minute, that's not going to work. But I have considered even using these 90-degree standoffs to force the coax up and then back down, things like that. But we can deal with the mower another day, can't we? Let's just get these wired up. Also, every one of these needs tuned. The physical length of each vertical we need to toy with. Now, we ground a lot of these away because we were worried there wasn't enough depth. We did that on the last video, if you remember, as well. It just so happens these 259s are long enough. In fact, they're very long. Now we could pin these direct to the ground, thinking about it, and let the mower just get annoyed. I've got a ton of ferrites to put on here as well. Right, this is antenna number 1, which is southwest. Antenna 2, the default, is that one over there. That means without any power, the natural direction is northwest, which is kind of North America. This is quite springy stuff, but it's the sort of professional berry flex, if you know what I mean. And there should just be enough room, I've worked out. There is. So, antenna 1, that one there. And then we're just going to have to get cute with all the wires under here. That's actually the longest one. Anyway, when you go and buy something like this, you forget the amount of coax you need. And also this 75 ohm stuff. I mean, a lot of ham radio operators have got 75 ohm, you know, because of friends and whatever else. But I've got to thank Messi and Paoloni, Stefano, for sending me this reel. Actually, it really helped me out of a hole, and I knew it was good quality stuff, you know. Alright, so this is, I'm just doing some untwisting. This This is number 2. Just a mild bend. I might have to put some more rubber matting down here because there's going to be a bunch of wires down here. It'll really confuse the mower, you know. So we're going to have to pin that on the ground. We'll put it in a wide arc out the way. Can you imagine doing all this work and then finding out that for some reason you got all the dimensions wrong? It just doesn't work. Oh my goodness. I'd give up the hobby and take up fishing or something. So you need to use 85% coax, because if you use a velocity factor of less than that, you won't have enough room. You'd have to go to a 3/4 length, not a quarter of wavelength. Number 4. Right, can we get rid of that twist before it goes in? Now I definitely can't get my fingers on this one. I'll go slowly. We can shut the cabinet. Yeah, we can. Alright, so tomorrow we'll tidy all the coax up. We'll put the new run in from up the top. We'll take down every 40-metre aerial antenna, put the meter on it and get it exactly at 7.15. So they all need to be. Oh no! I've got to tune them 4% lower or something. I've worked it out. They need to bottom them all out at 7.07 because once they're all in, they'll come up about 100 kilohertz. Alright, I will see you tomorrow. Alright, so it's the next day. Well, actually it's the day after the next day. Because yesterday what I did is I spent an age freeing up all the cables that went from the bottom of the tower up to the shed, just so I could pull some cables down, free up the cables at the bottom of the cabinet. And I got called away just as I was finding some silicon spray or something to free up these connectors. I appear to have found a reasonable solution to all this. Let me just drill a hole here. That holds it away really nicely. Now this is probably not the right stuff, and the reality is, I probably need to put new connectors on here, but we'll just see if that will seat better now. Well, actually, I think half the problem is, well, it should fit in. Okay, it will. It will just go not very well. I've got this giant heat shrink stuff, which I thought might be quite an interesting concept. We'll put that over there. We'll heat shrink the top only. And we'll probably need a little cable tie to hold it in place. Yeah, okay. We'll do that. So I'm going to do these on all 4, and then we'll start measuring the SWR on each element. Okay, so that's actually worked out quite well. It gives it a little bit of, weather protection. And to be honest, I don't know why I'm bothering measuring this, because it's actually far too long. But anyway, I'll just see where it's resonant at the moment. Probably about 6.5 or something. For those of you who remember the old pirate band, 6.66. I've got a perfect tune. So, okay, let's take this down and take some off this. So, I've already taken a bit off. I'm going to take a little bit more off. We will go to there. We'll keep that. We might need to graft it back on. Is it going to make any difference of me sitting here? Hardly. The wavelength is 40 metres and on this tiny little dot sitting here. Well, big dot really. 6.78. We're at 6.6. We keep taking stuff off, I think. Oh, that tripod is exactly where I want to put this. Probably start to get a bit more accurate now. Okay, it's looking better. We can get really accurate now. So it's 7.031. All right, 1 to 1 basically. So I can exactly calculate what I need to remove. I'm going to aim at 7.06. 4 centimetres. .7052 is the datum line. 7052. Right, I'll tune everything at 7052 and get back to you. So the end of my wire is currently right there, okay? So I've just measured 13 centimetres, I don't know how many inches that is, it looks about 5, and marked it. So now I'm going to take this off, graft the two together, and then cut it exactly the right point. You know, some people say, oh, I mean, it's easier to cut a wire than it is to extend it. Yes, it is, but it's not the end of the world, you know what I mean? Oh, that's another 2 minutes. Tough. If you make your best guess to start with, you'd be surprised sometimes you cock on. That's what I've just done. I've made it. So I've put you all on that curve. Well, all 4. 7051. That's 1.12, look. I am terrified. We've got to get the coax, and that's the only thing to connect. But because I haven't made everything, I don't know. I just don't know what's going to happen. Because this is bought in, isn't it? Yes, I've made the antennas, the radial field, and a lot of stuff. But the actual control box, the genius switches and everything, you know. Anyway, sometimes you've just got to pray and hope, haven't you? While I'm laying this down, let me just replay something Tim Duffy and I spoke last year or beginning of this year, I can't remember, and I asked him about the 4 squares. So let's just drop that conversation in, it's quite interesting. Am I right in saying then, Tim, that not only because you've got the on receive now, because you've got this front to back, not only have you got your main lobe, which is 4 or 5, if you're lucky 6 dB gain coming in, but because you cannot hear from behind,
right?
Surely it must feel better than 5 or 6 dB because you're just not hearing anything behind you. Is that right?
Right. And on 40 meters, Callum, and I'm sure this is the same thing in the UK. There's a lot of noise, so that front to back ratio, beats down the noise off the back.
Yeah. Let's get a demo going and see how well this thing performs. Can't do it now because it's daytime, so we're all going to have to wait until tonight or very early tomorrow morning. Let me just make this tidy at least. Now, it kind of looks finished, but it's not. What we've got to do is we've got to choke this one off severely, and at the feed point of all of these, I've bought a ton of ferrites to put on there as well, but everything needs choked off. So actually, one of the reasons I mentioned cost the other day, putting a system like this in is not cheap. And I've got a cheap power meter, which we need to hook up with a tiny patch lead. I think we can read power without having 12 volts, because I've got a little remote camera, just so we can watch the dump power. Make sure it doesn't rise, because if it's rising, that means there's a fault in the system. So I sit down and do some really basic tests and remember everything I haven't done. All right, so we haven't excuse me, we haven't grounded the tower to the radials. We haven't put ferrites on, nothing. But anyway, you know, we can just do some really basic tests at the moment. Foursquare. No. We have a problem and I just can't work it out what the problem is because I've got high SWR. Does it resonate down there where it should go? No, it's all over the shot. So let's go out and review what we've done. It's like all my worst fears. You know when you get like an inkling, I was so focused on, I wonder what the performance is like, that I actually forgot which SO239 I'd plugged into, hoping I've got it wrong. No, I've got it right. Damn. I mean, frankly, even if I got the phasing wrong, I should still get a tune, you know. All right, in fairness, we haven't tested the lead to the dummy load, so we're going to take that out and test it. We can ignore the line here. I'll just check I don't need to check the phasing lines because it doesn't, even if they were wrong, it would still work. All right, so, well, I mean, let's at least check this. The only thing we haven't tested, the dummy load. Well, the dummy load works perfectly, so it's not the dummy load. We can put that back in line. It's perfect. Okay. I mean, I get customers emailing me like, what do I do? What do I do? And it's because one of the reasons we find it difficult to fault find is because we're in a bit of a fluster. We got an adrenaline flow and that sort of thing. Sometimes I always tell people just go and have a cup of coffee and think it through. So we know the dummy load works now. So we'll move the dummy load, we'll put it in place of the Foursquare, and we'll just make sure that that whole signal chain through to port number 8, which is down here, actually works. I phoned Mike this morning and we came up with a bright idea of using a T-piece. Why using a T-piece? Because at the moment we've got 75 ohm phasing lines from this box to each of the antennas. Well, if we just take 2 of these verticals here, and we know we've got 75 ohm quarter wave at the right velocity factor, if we put a T-piece just between 2 of them, we should be able to put an SWR meter all the way up there somewhere, right, and see that we're getting a SWR, a resonance, and an SWR better than 1.5 to 1, because it will look like a phased array broadside. Right, so that's what we're going to do. We'll test 2 and then the other 2, and then that way we can work out, is it the little box of tricks that's doing it, or is it something I've done wrong? And we are due a massive storm in a couple of days' time. There's a little bit I want to get done in this field and get the grass cut. So we're kind of making a, if you think about it, a 2-element phased array, but without a delay line. So if you get the 2 verticals, our signal, if we did actually use it, we get about 3 dB gain through the middle. You get a really good match. This is how you make a phased array. And let's get the right one of these. That is the transmit line there. So all we do now is plug in the SWR meter to the 31 meters of coax we've got at the top here. And that will at least prove something, won't it? So like all projects, there's always contingency for a bit of a cock up. So that's antenna 1 and 2, and it's absolutely perfect with the phased array configuration. So let's do the other 2. So some people are going to be thinking, oh, you know, you buy something new and it should work out of the box. And, you know, it does. But that's why, you know, cars have... Oh, shit, I can't get this thing off. Cars have warranty periods. You know, everything has a warranty period, doesn't it? So, I mean, I bought an ACOM... I can't get this off. Oh, there it is. I bought an ACOM 2020S, the most expensive amplifier. Well, I didn't buy it, someone else did. That you can buy, basically, from the ACOM stable, and it stopped working, you know, after 2 minutes. I mean, it's just the way of the world, you know. Sometimes, you know, something fails. I'm not blaming ACOM for that. I'm sure they made it very fine, but something out of their control went wrong. Now, it could be as simple, it could be something simple as a, you know, a $2 component or a, you know, a bit of a solder tag somewhere. Hang on, I'm just finding the right one. So think twice about blaming a manufacturer if something goes wrong. You know, occasionally, you know, Lockie sold us an SO239 and it comes loose, or well, I say occasionally, I mean, it is literally less than 1 in 1,000. But it can happen, can't it? You know what, I'm still connected. I think I bottomed these out at 705. Let's have a look. 705. Yeah, 1.19 to 1. So it is the next day. Yesterday I went through the whole signal chain with a dummy load and gave up. I went home. I thought, well, what's going wrong? Sometimes I was getting a fault, sometimes I wasn't. I could never get an SWR all the way back at the shack. When Mike was up on, a couple of Saturdays ago, we put 13 PL259s and some Coax. How can you put 13 on? Because it's an odd number. Coax normally has one on one end, one on the other. That's because it genuinely had already one on it. And I said to Mike, let's test it, and we did, and it worked. However, it was intermittent, and I'll tell you why. It was probably the one that I used when I did the demo of how a normal person puts a PL259 on. And I'll tell you what, oh, that's odd. Because it's those PL259s with a tiny pinhole in the side. They're not for normal people. Normal people want Coax like this, which has a hole, right? So you can, you know, put a dob of solder on the end. So although it might not be fixed, we've found one of the problems. Yeah, I think it probably is fixed, to be honest. Right, number one, that is number two. I replaced the Coax run, this one I'm walking next to, because of that duff connector. So anyway, let's see how we get on. So I mean that's the curve. But you've got to remember, because of we've got the dummy load, you always get a great match, which is why it's important on transmit to have the dummy load connected at, well, obviously, but you need the dummy load anyway. But we need an SWR power meter in that cabinet with a little patch lead, and I've got a cheap Wi-Fi camera we can connect, so we should be able to watch the dump power, the physical power that's been dumped. And if it's more than, you know, 1 or 2%, we know we've got some mismatch going on. All right, let's connect it and get into the shack and have a look.
Mike Italy, Oscar. Mike Sure Z, Japan, Kilo 1, Bravo, Quebec, Sierra. Oscar, Kilo 2, Mike Italy. Sierra, Papa 2, Alpha, Sierra. Japan, Kilo 1, Bravo, Quebec, Sierra. Good morning, thank you for your call. Good evening. You're 5 and 9, near Tokyo, QTH near Tokyo. My name is Yoshi, Yankee, Oscar, Sierra, Hotel, India. Sierra, Papa 2, Alpha, Sierra. Japan, Kilo 1, Bravo, Quebec, Sierra. Over.
QSL, my name, you are 5 and 9 plus, back to you.
Okay, Alex, QSL. Thank you very much, North Poland. Thank you very much, nice fast contact. Sierra Papa 2, Alpha Sierra, Japan, Kilo 1, Bravo, Quebec, Sierra. 73.
I'm sorry.
Oscar, Kilo 2, Mike Italy. Oscar, Kilo 2.
Is it correct?
Negative. Japan, Kilo 1, Bravo, Quebec, Sierra. Japan, Kilo 1, Bravo, Quebec, Sierra. Copy?
Roger. Japan.
Oscar, Kilo 2, Mike Italy. Oscar, Kilo 2, Mike Italy. Raja. Thank you very much. Nice contact, Alex. 73.
73, bye-bye.
Bye-bye. What is your radio? QRZ, Japan, Kilo 1, Bravo, Quebec, Sierra. Oscar, Kilo 2, Mike Italy. Oscar, Kilo 2, Alpha, Charlie, Alpha. Italy. Alpha, Charlie. Uniform 3, Oscar, Kilo 2, Mike Italy. Radio Uniform 3, Alpha, Charlie, Alpha. This is Japan, Kilo 1, Bravo, Quebec, Sierra. Good evening. Yeah, thank you for your call. You are 557. My name is Yoshi. Yankee Oscar Sierra Hotel India QTH near Tokyo. How do you copy? Over.
If you are considering a Foursquare, do not underestimate the amount of connectors, coax, time and effort it takes. I know I've got the mast as well, and I just add more and more complexity, but I've just proved to myself that thing works. All right, enjoy your radio. Catch me soon, and we'll go and play on 40 and on 80 because we've got the full-size 80 meters to try out. All the best now. Bye for now.